So in this video, we'll look at the basis of an analysis technique which is useful when analyzing a circuit with more than one sources, and that is known as superposition. Recall that superposition is just a general property of linear systems that says if you know the response of a system for a particular input, say x1, and you know the response for another input, say x2, then assuming homogeneity in the additivity property hold, which is the definition of superposition, then the output to a weighted linear combination of those inputs is simply the weighted linear combination of the outputs. So when analyzing a circuit via superposition, you want to incrementally, one by one, find the response due to one source, turn the other source off. We'll talk about what that means in a second. And do that for each source, and then combine the total response as the sum of the individual responses. So for the 6-volt source in this particular circuit, to find the response due to it alone, we need to deactivate the 3-amp current source. And recall that to deactivate a current source, you simply replace it by an open circuit. So it's not going to have any effect in this specific example. We're interested in finding the response V. Upon removal of the current source, this just becomes a simple voltage divider circuit. So the voltage which we realize across the 4-ohm will be proportional to the 4-ohm relative to the total series resistance of that circuit, which would be 8 plus 4, or just 12. Cancel, and you simply get 2 volts for the response due to the 6-volt source. For the 3-amp source, we remove the 6-volt source, and when we remove a voltage source in superposition, we short that. So similar to the previous analysis, this again results in a divider circuit, only now we're dividing a current. Therefore, in order to solve for, we'll begin by the current through the 4-ohm resistor. Take that current and divide it. If we want to find the current through the 4-ohm resistor, it's going to be equal to this expression. Recall back from circuit division. So we're going to get 8/12 of the current through the 4-ohm branch, canceling. 3 goes into 12. 4 times, 1 time, that will give me 2 amps. Therefore, I can find V. And I should be a little careful here. Since this isn't the total V which I wish to find, I'll add a prime notation, V prime. Here I'll add a double prime notation, V double prime. So V double prime is simply going to be the current I4, which we solved for above, times 4. So that will simply be 8 volts. Therefore, we can say that V naught is V prime plus V double prime, which will simply be 10 volts.